Good evening, everyone, and thank you so much for coming to tonight's Tech Talk. Tonight, we are joined with Isaac Bocage, who will be talking with us about web servers. My name is Andrew, and I will be moderating our talk this evening. If you have a question for our speaker, please send a direct message to me, and I will present those at the end. We will answer as many questions as time allows. Before we get started, let's unmute ourselves and give our speaker a big round of applause.
Let's go, Isaac.
Isaac.
Okay, Isaac, the floor is yours.
Hi, my name is Isaac Bocage. Thank you for coming to my tech talk. Before we begin, I would like to thank Seismic for sponsoring this talk. So today we're going to talk about web servers, focusing on what they are, how they work, and practical applications in a web development context. So what is a server? On the software side, a server is a program that provides services to client programs. On the hardware side, a server is a shared computer on a network, usually powerful and housed in a data center. Put those definitions together and you get any computer or system that provides resources, data, services, or programs to other computers known as clients over a network. Usually, we think of servers as ultra-fast computers stored in climate-controlled rooms in super secure buildings. But technically speaking, a server could be a laptop sitting on someone's bedroom floor with a post-it note stuck to it saying, "Please do not touch me." The term server is just used to describe the role a computer is playing, which is to serve other computers. There are many types of servers out there, like database servers, email servers, gaming servers, cloud servers, the list goes on. And you might have guessed these types of servers get their name according to the types of data that they serve. So what is a web server? Building off of the previous definition I mentioned, a web server is a computer that stores web server software and a website's component files, for example, HTML documents, images, CSS style sheets, and JavaScript files. A web server connects to the internet and supports physical interchange with other devices connected to the internet. A web server also includes several parts that control how web users access hosted files. At a minimum, this is an HTTP server. An HTTP server is software that understands URLs or web addresses, and HTTP, which is a protocol your browser uses to view web pages. An HTTP server can be accessed through the domain names of the websites it stores, and it delivers the content of these hosted websites to the end user's device. So how does it work? A web server functionality is based on the request response cycle. In it, a user specifies the URL they want to access in the address bar of their browser. We call this the client. The client then fetches the IP address of the domain name. This allows the client to contact the specific server they want data from. The client requests data from this server using a REST API, which includes HTTP methods. The web server will then send back the requested data via HTTP for the browser to render or otherwise interact with. If the file doesn't exist, an error message will be sent in place of the data requested. Let's talk a little bit about REST, which stands for Representational State Transfer. A RESTful API is a standardized interface that allows two computer systems to exchange data over the internet efficiently. In the context of web development, this is often used to retrieve and display web pages and their content. For instance, imagine a web developer based in San Francisco who is working on a project that requires fetching data from a server located in London. The server hosts a website with dynamic content, and the developer needs to request specific web pages or data from it. Using a RESTful API, the developer can send HTTP requests to the server's endpoints, specifying the resources they want to access. The server in London processes these requests and sends back the requested web pages or data, which can then be displayed on the developer's website or integrated into their application. RESTful APIs support this information exchange by adhering to standard communication protocols, enabling the seamless retrieval and display of web content from servers located in different countries. This ensures a smooth and efficient web development process. Some of the benefits of RESTful architecture include a simple standardized approach to communication between clients and servers. They are scalable and stateless. As your service grows in complexity, you can easily make modifications and don't have to worry about what data has changed. They're also highly performant, mainly due to caching. So let's move on to HTTP. This stands for Hypertext Transfer Protocol. It's a protocol for fetching resources from web servers, and it's the foundation of any data exchanged on the web. In this protocol are several methods used to manipulate data on a web server, but the most commonly used are get, post, put, and delete. These four HTTP methods lay the foundation for CRUD functionality, which allows developers to make interactive web applications and services like social media sites. Web servers are equipped to handle these HTTP requests because of their built-in RESTful architecture. Additionally, there are status codes that are used to give feedback to clients from the server on the status of the requests. Status codes in the 100 class are informational. Status codes in the 200 class are designed to show successful reception or understanding of requests. Codes in the 300 class indicate redirection or the need for further action to complete the request. Codes in the 400 class represent a failed request due to errors on the client's part. And finally, codes in the 500 class are used to alert that the server failed to process an apparently valid request. If you want to learn more about these status codes, I recommend Googling status dogs and HTTP cats. It'll be well worth your time. I also want to talk a little bit about some of the web server applications available for developers today. First, we have Apache. Launched in 1995, Apache has been a widely popular web server application for decades. It offers extensive support for various programming languages and modules, allowing for highly customizable configurations. Its .htaccess feature enables directory-level configurations without server restarts, making it ideal for sharing hosting environments. In short, Apache excels in compatibility and flexibility, serving a broad range of websites from small to large. Next, we have Nginx. Probably the most used web server application today, Nginx is known for its high performance. It is designed to handle a large number of simultaneous connections with a low memory footprint, making it efficient for high traffic websites. Its event-driven architecture enables it to serve static content quickly and act as a reverse proxy or load balancer, offering improved scalability and resource management. Another web server application worth discussing is Lightspeed. Lightspeed stands out for its performance and efficiency, particularly in dynamic content for delivery with built-in cache mechanisms that significantly reduce server load and improve page load times. Compatible with Apache's mod rewrite and htaccess, Lightspeed offers an easy migration path for existing Apache users looking for performance upgrades without major configuration changes. Each of these applications are open source, so you can easily start using them today. As I wrap up, I wanted to briefly mention other things to consider about web servers. First is HTTPS. It simply stands for Hypertext Transfer Protocol Secure. It adds a layer of security by using SSL and TLS encryption, protecting data in transit. This prevents eavesdroppers from understanding the data exchanged, making HTTPS essential for maintaining privacy and security online, especially for transactions and sensitive information. I recommend using this wherever possible. The second is serverless architecture. Serverless architecture refers to a cloud computing model where the cloud provider manages their server infrastructure, dynamically managing the allocation of machine resources. Instead of pre-provisioning and managing servers, developers deploy code and the provider executes it in response to events such as HTTP requests. Serverless describes the developer's experience with those servers. They're invisible to the developer who doesn't see them, manage them, or interact with them in any way. This allows for building and running applications without thinking about servers, leading to cost savings on idle resources and scaling without manual intervention. It's ideal for applications with variable workloads because it enhances your development agility. And lastly, HTTP3. HTTP3 uses similar semantics compared to earlier revisions of the protocol, including the same request methods, status codes, and message fields, but encodes them and maintains session state differently. However, partially due to the protocol's adoption of QUIC or QUIC, HTTP3 has lower latency and loads more quickly in real-world usage when compared with previous versions. In some cases, over 3 times faster than with HTTP 1.1, which for many websites is the only version deployed. In summary, we went over what a web server is and how it differs from other types of servers, how web servers work. We discussed REST APIs and HTTP. We looked at some notable web server applications and briefly talked about where the web server space is heading. Here are my works cited. Once again, I'd like to thank Seismic for sponsoring this Tech Talk. If you'd like to talk more about the subject, connect with me on LinkedIn and GitHub. And thank you for listening.
Okay, everyone, now let's go ahead and unmute and give another round of applause for Isaac.
Let's go,
Good
Isaac.
job,
Isaac.
Good job, man.
Good job.
Okay, Isaac, we do have one question from the audience for you. This question is from Sharmi, and they ask, can you provide examples of a computing service that uses serverless architecture?
Sure. Web developers can use services like AWS Lambda and Amazon API Gateway to build web applications in a serverless manner. Serverless solutions are designed for event-driven, highly scalable, and managed execution of code. This enables developers to focus on application logic, while AWS manages the underlying infrastructure and scaling, which makes it all easier to create and deploy a modern web application.
Excellent. Thank you so much, Isaac. That seems like all the time we have for tonight, so we will conclude our talk here. Thank you all so much for joining us, and have a wonderful evening.